Welcome to part 2. This is episode number 6 of CMath Run. We are in part 2 looking at statistics. Today we're going to be looking at advanced statistical features in the Casio Prism. So I'm going to go into my statistical mode. I've got my data list. I have cleared it all out. Today's question is, can we do a hypothesis test on some data that we generate randomly? So I'm going to go to the beginning here. I'm going to go to options. Let me go back up to the top. I want to input a formula where I'm going to put in a list of numbers generated by the calculator at random. Going into options, probability distribution F5, random, which is F4. I'm going to go with random binomial distribution with successes. We're going to do 50 trials. Probability of a success, let's go with 0.45. And how many times do I want to repeat this experiment? I'm going to do it 100. What my question is here is, I have a slightly unfair coin. Probability that it comes up one way or the other is 0.45. I'm going to flip the coin 50 times, record the number of successes, and I'm going to do that 100 times. And I'm going to calculate to see if the true mean is actually less than half of that, less than 25. So it's going to take a little while to go ahead and do that. We're going to go through the whole statistical process. We're going to look at the different types of graphs I can generate. So on the first trial, 20 successes, second trial 20, third trial 25, fourth 22. So based on what I need to know for statistics, what I want to do is take a look at my basic one variable statistics. I want to look at the mean and the standard deviation. Mean is 22.67. I've got more information towards the bottom. I got the pink arrow showing me. I got my quartiles, my median, quartile 3, my max, and my modes. It says that 23 is a mode and it showed up once. There's 16 times the mode of 23 came up. That's the frequency. How many modes? There was only one mode. That mode was 23. And it came up 16 times in this out of these 100 trials. So I'm going to exit. Any good statistician knows you should take a look at your data. So I'm going to set up my graph. Right now I've got it set to do a median box plot, which is what I want to do. So I'll go ahead and graph my median box plot. There is no outliers, no skew. Exit out of there. Let's take a look at one more type of graph. We're going to look at the normal probability plot, sometimes called a normal quantile plot. It's just a button push. Exit out of here. Go ahead and graph. Linear pattern, good sign. If it's nonlinear, if the pattern's nonlinear, then you've got a problem with some skewness with your data. So let's exit that. Let's do some advanced statistical features, which include the being able to do some intervals and some tests. Let's do a confidence interval. It's going to be F4. I'm going to do a t-interval, a one sample t-interval. My confidence level is 45%. I'm doing this data out of the list. It asks me what list is it in, is there a frequency, save residuals. Now I'll go ahead and execute, calculate my confidence interval. Gives me my upper and lower limits of the confidence interval, standard deviation for the confidence interval for the sample, and the mean. Is this an unfair coin? Let's do a statistical test on it. We're going to go with a t-test. This is a one sample t-test based on the list. While we're assuming that our mu is actually lower. So I'm going to go as less than. The average is 25 out of 50, so we should get an average of 25, but our average was 23. Oh, I don't need a decimal there. So I'll make this a 25. That's the null hypothesis there. It's actually less than that. It's 45%. So let's see what 45% of 50 is. And then we'll round up the answer. So the answer is about 23. So I wasn't that far off. In fact, I might actually be a little high. Let's do that one again. 0.45%. Of the time it comes up heads, and 50. So 22. So my average is 23, upper part of 23. So I'm going to change that to greater than. And I'll come back and do one for not equals in a minute. Save my residuals. No. I'm going to do two things. I'm going to draw. Gives me my normal curve. And it shades the probability. I have an option of either showing the t-value, and it highlights my t, where it's at is my critical t there. So I want to exit. Let's draw the same graph. And now we'll find the area under the curve, or the p-value for this question. Probability of this happening is 0.32. 32% of the time this happens. Not enough there to reject the null hypothesis. Or I could just simply calculate, and the calculate does the same thing. Let's do one more. Let's do a proportion. So I'm going to exit. I'm going to delete all this information. F4, delete all. Yes, I do. Let's repeat this. We'll go up to the very top of the list. I'm going to grab some information, generate some probability from a random binomial. So I'm going to go with a proportion. 50 trials at a time. Probability of a success in this case is 0.25. Probability of guessing correctly on a 4-item question test, I'll do 100 of them. And since I want a proportion, I'm going to divide by the number of trials in each one, which is 50. Again, this is going to take a little while because we are doing so many of them. It still generates them fairly quickly. Once it gets all this information, we're going to look at some more graphs quickly, and then we will do a confidence interval and a statistical test on it. So I'm going to jump back to my original information. So I'm going to go graph. Let's graph the first one, which is a normal quantile plot, normal probability plot. That looked pretty good to me. Now let's do a histogram this time. Histogram of the data. Graph. It's asking me for some bin information. I'm going to go ahead and assume that that bin information is okay. Looks normal. No major skew, no major problems or issues. One more graph. Notice I have not had to change the window or make any adjustments like that. I'm going to go with the median box plot. Exit out of there. Graph it again. Got one long tail here. Nothing major, no major flaws, no major problems. Again, I want to do my confidence interval. This is a proportion, so I'm going to go a z interval, one proportion z interval. 95% confidence. I should probably look at my one variable statistics here. .256. One proportion. So I'm looking at 0.256 out of 50. So I'm going to just round that up to 13 out of 50. I'd repeated the trials 100 times, so the 100 is not what I'm looking at there. So I'm going to go ahead and execute that. I'll calculate what that interval is. Low and high end, which captures my 0.25. And very quickly, I'll calculate a statistical test on it. It is a one proportion test. It's a z-test. I'm just going to go a two-sided test on this one. We'll do a two-sided not equal to 0.25. 13 out of 50, that information got transferred over, you notice, from my earlier calculation. Again, I can draw. It shows me the two sides. Calculate the p-value, or calculate the data. There's your data. I'll just show you the other options real quick since we're here. You can import data from CSV files, so if you have CSV files from Excel, you can import those, or from homework test data, things like that. That is episode 6 of CMath Run. This was the statistics, advanced statistical features. Stay tuned. Next week we'll be looking at some of the other features of the Casio Prism. The 90-day trial is now available on the Casio website. If you would like to get a hold of it, please go on the Casio website.